Okay, so these are a review of sine law. Does anybody remember how we know that we're going to use sine law? What information do we need in order to do sine law?
Was it that you're given the same angle and side or
Yeah,
something like that?
perfect.
I know how to find it. I don't know how to explain it though.
What you said is perfect. Like you have to have angle P and side P, or angle A and side A, or angle X and side X. So yes, you have to have an angle and the opposite side length. I call it a loop of information. I need to know an angle and the opposite side. That's my indication it is sine law. So on both of these, you guys can see that in the first one, I have angle P and side P, and in the second one, I have angle B and side B. Okay, so I have a loop there. Then you need to ask yourself, am I solving for a side or an angle? Because the formula is just inverted depending on what you're looking for. So for question A, am I solving for a side or an angle?
A side.
Perfect. So it's telling me I'm looking for R. It also says here in my instructions that I'm looking for a side. So I want my sides to be in the top. I'm going to just rewrite my sine law formula so it's reflective of the letters in this triangle. So PQR, sides or lowercase letters in the top. PQ and angles in the bottom. Sides are lowercase letters, angles are capital letters. All right. What information do I know?
You know the angle of R and the angle of P.
Good. So P is 68. Angle P is 68. And R is 57. Do they ask me or give me Q at all? Side Q or angle Q?
No.
No, so I'm going to ignore this part of my formula. I'm going to use P and R. So angle R is 57 degrees. Okay, what else do we know?
The side length of side P is 8 centimeters.
Good, and I am solving for R. So I filled into my formula everything except for one variable, the variable I'm solving for. Here we go. So what I do is I verify the variable that I'm solving for. So I'm solving for R. It's right here. How is this sine of 57 attached to R? Addition, subtraction, multiplication, or division?
Division.
Perfect. What's the opposite of division, or how could I undo this multiplication? The division, sorry, I said the opposite thing.
Multiply it out.
Good, multiply it like I just said. Good, multiply both sides by sine of 57. So I'm gonna multiply by sine of 57. That will isolate for R, because that cancels. What you do to one side, you have to do the other. So I'm gonna multiply sine of 57 over here. So what you're going to do on your calculators is in any order, because this is multiplication and division, sine of 57 times 8 divided by sine of 68. Sine of 57 times 8 divided by the sine of 68. I'm just going to open Desmus here, the calculator, so we can do this together. So sine 57 times 8 divided by sine 68. What are you guys getting?
7.25.
Awesome. I've got 7.24, but let me make sure I entered it in.
Yeah, sorry.
Okay, I wasn't
That's
sure if I
right.
entered it in right because I was just going off of memory. What did this question ask us to round to? Did it say?
Nearest 10th.
Okay, so we just need 7.2. So R is 7.2. R equals 7.2. Is there units? I think there is centimeters. Questions on solving for sides using sine law.
I have a question about the test.
Okay, okay, so we already determined this is sine law because I've got this loop right here. Okay, so this is sine law. Am I solving for sides or am I solving for angles?
Angles.
Perfect. So my angles need to be in the top. So flip the whole formula upside down. This is an ABC triangle, so that's nice. So I'm going to have sine A, angles in the top, over lowercase a, because that's my sides in the bottom, equals sine B over side B equals sine C over side C. What do I know?
You know, so it would be like, okay, you know B, both the angle and the side length, and then you also know the side length of A, and then you would like leave the blank empty for the angle of A, because that's what we're solving for.
Good, we're solving for, perfect. So I'm just writing that all in there. And Lauren, we're completely ignoring the C's, right? We don't need angle C or side C.
Right.
Okay, so I'm going to cross that out. Okay, so I have what Lauren was saying. I plugged in angle B, side B. I don't know angle A and side A. Okay,
One question.
Yes, Makai.
So for the first one, we put like the angle on the bottom, but the side length on the top, I think.
Mm-hmm.
And then for the other one, we did the opposite. What's the difference?
If you're solving for sides, you want the sides in the top, like our first one. If you're solving for angles, you want the angles in the top, like the second one.
Oh, okay.
So they're literally the same formula, but you want the variable you're solving for to be in the numerator. It makes it easier to isolate.
Okay.
So if you're solving for sides, sides in the top. If you're solving for angles, angles in the top.
All right. Thank you.
You're welcome. Okay, so A is my variable. I'm going to ignore the fact that sine is attached to it right now. Right now it's being divided by 16. So what am I doing with my 16?
You're going to multiply it to the other side.
Good. I'm going to multiply both sides by 16. That cancels. Multiply over here. Okay, in your calculator, you're going to do sine 80 divided by 18 times 16. And again, the order doesn't matter because it's multiplication and division. Sine 80 divided by 18 times 16. Sine 80 divided by 16. I think I'm doing this in the right order. Times 18. Is that right, guys?
Yeah.
Except for my
No,
18. Hold on.
Just kidding.
Is it divided by 18?
Yes.
Oh, okay. Okay, awesome. Thank you, guys. Okay, I got to get out of the denominator. If you're using Desmus, make sure you get out of the denominator when you do the multiplication part here. Okay. I'm getting 0.8753846, so on and so forth. Does that feel right to us? A 0.875 degree angle?
No.
No. Good. Okay, so when you look at your formula, that's what sine of A equals. 0.8, blah, blah, blah. Okay, but how do I turn that into an angle measurement?
You have to square root it.
Not square root it. This is the sine of A. So how do I get sine off of A?
You bring it to the other side.
What will that look like, Mikhail, on your calculator?
Sine, and then would be multiplied by 0.8.
What will it look like when I move sine across the equal sign, guys?
It'll turn negative.
You're gonna have sine -1 is the inverse function when I move it across the equal sign. I actually remember I'm gonna write this the way I want you to put it in your calculator. So you're gonna have sine -1, and then I want you to use your answer button. So do sine -1 of your answer so that it puts that crazy long decimal back in there for you guys. Sine -1 of your answer. And it will convert that to an angle. So let me grab Desmus. If you're using Desmus, you have to hit the function to get sine -1. My answer button, so go back to main, is right here by the plus sign on the bottom. Hit answer. Oops, it went in twice. And how many of us are getting 61 degrees?
Yes, I got that.
Wonderful, 61 degrees. Sine -1 of your answer, and then we'll just round that to a whole number here, 61 degrees.
For right triangles?
Very good. SOHCAHTOA can only be used for right triangles. There has to be a 90-degree angle. We have to have a hypotenuse so that we can then identify the opposite and the adjacent. So SOHCAHTOA is limited to only right triangles, okay? So then we use sine law and cosine law for any non-right triangles. And here's the formulas. I will give them to you. They look complicated, but these are ones where you just grab what's given to you in the triangle, plug them in the appropriate space for the variable, and then we have to just get comfortable with our calculators. Okay, so keep your calculators handy, please. I'm giving you the rearranged formula for angles. So this one here is isolated. The top one is isolated for a side length. A squared equals B squared plus C squared minus 2BC times cosine A is for sides, okay? And I've rearranged it. So if you're looking for an angle, I've isolated for your angle. So we'll use this one. We will use the same process as sine law. We're going to first make sure we determine, is this the appropriate situation to use cosine law? Then I'm going to ask myself, am I solving for a side or am I solving for an angle? So that I can make sure I use the one that's rearranged to make my life easier, because we definitely want that with these formulas. So let me show you an example. Oh, in case you're curious about where cosine law came from, it's right here. You guys can read that over, before you go to bed tonight if you'd like to. It's right there. But let's look at this triangle. It's asking me to solve for side A. First of all, could I use sine law in order to find side A, given what's here on this triangle?
No.
No. I have angle A, but not side A. I have side B, but not angle B. And I have side C and not angle C. And I have no way of solving for either of these missing angles. I do not have a loop of information. So by default, it is not sine law. Okay, so this one is going to be a cosine law question. And I'm solving for a side length. And I've labeled this one an ABC triangle. And I have said we're solving for A so that we can see how this formula works. Carefully copy it from the previous part of our lesson. And I just did that on purpose here, guys. I actually copied it wrong here. Put the wrong letter in. BC. This needs to be BC. B squared plus C squared minus 2BC times cosine A.
Mr. Reed,
Mm-hmm.
you know how like before we would use like capitals and lower cases like in our equation?
Yeah.
like how come there's only lower cases now
No.
except for the A?
Because in cosine law, if you're solving for a side length, if I'm solving for side A, I need to know the angle across from it. So I would need to know angle A. So you actually only need one angle, oops, and the two sides kind of attached to that angle for cosine law. Or if I'm solving for an angle, I actually only need all three sides. I don't even need to know any of the angles. But the rule
Okay.
still is the same. Angles are capital letters and side lengths are lowercase letters. So that rule is still the same.
Okay.
Okay. So you just need to know different information compared to sine law. Okay.
Isn't cosine
Yes, Mackay.
law for right triangles?
Say that one more time, Mackay.
Isn't cosine for right triangles?
Sine is for right triangles, but sine law is for non-right triangles. So SOHCAHTOA is for right triangles. Sine law and cosine law are for non-right triangles.
Oh, okay.
Okay. All right, let's plug in what we know here. What is side B's length?
Seven centimeters.
Good. So I'm gonna plug that in. What's C?
Five
5.
centimeters.
Perfect. I'm gonna repeat B and C, so 7 and 5. And how big is angle A?
45 degrees.
Awesome. Now, most of us have calculators. We can actually plug this in one step. Your calculator will do BEDMAS for you. So it's a matter of just getting comfortable with your calculators. There are some calculators where you cannot do this in one step. If you have that kind of calculator that as soon as you enter in, as soon as you hit plus or minus, what's in the screen disappears to that new part of the calculation, this is going to be, you're going to have to get used to how to enter this in your calculator. But if your calculator shows it all in your screen at one time, you'll be fine to put this all in one step. So we're all going to do this together. I'll just do this in Desmus, but grab your calculator. 7 squared plus 5 squared. The first part of this process. 7 squared plus 5 squared. Everyone's with me so far?
Yes.
Awesome. Minus, you guys know Lauren speaks for all of you if you don't speak up. Minus 2 times 7 times 5 times cosine. Remember to hit cosine. We're switching to cosine, not sine this time. 45. So 24.5. So just a question, is that the length of side A? Oh, come on.
No,
Okay, Brianna, why do you say no?
because we didn't square root it.
We didn't square root it. I can't even write on my board right now, guys. This A squared equals, well, there it goes, 24.5. So now you just have to square root 24.5. And that will give you side A. So do square root of 24.5. How long is side A?
4.95, but isn't that like 5?
Yeah, we can round that to 5.
Wait, that's so weird. That's what I got when I didn't put the brackets.
That's a mystery, Mackay. I don't know what happened there. I'm trying to make my handwriting look like I didn't have a kindergartner write my notes here, guys. My board is just not going smoothly for me today. Okay. So with cosine law, again, we don't have a loop of information. We actually have all of our information kind of like clumped on this one end. I have side C, angle A, side B, it's all up here. You basically plug it in your formula, grab your calculator. Because the formula says it's a squared equals, your very last step is just to take the square root of your answer, and that is it. You're done. You have your missing side length. Okay, so let's try that again. Let's try that on this one. Oh, that's an angle measurement. Let me see if I have a side length here again. Oh, you know what? I have a second one. I just have it down here. I do that all the time. I forget what I've done to myself. Okay, here it is. Again, we're solving for side A. And actually, I've made sure that on your evaluation, when we finish this unit, you'll be always solving for A. Okay, so you guys don't have to worry about any rearranging. So side A is what we're looking for. So again, I'm just going to rewrite my formula here. A squared equals B squared plus C squared minus 2BC times cosine A. And we'll plug in what's given to us. Just looking at this triangle, I know it is not sine law because I don't have a complete loop of information. I have angle A, but not side A. I have side B, not angle B. I have side C, not angle C. So by default, it has to be cosine law. And I also don't have a 90-degree angle in here. So I know it's not SOHCAHTOA. Okay. What is side B's side length?
40.
Perfect. So I'm going to put 40 in for B. 40 squared. What's C?
32.
Very good. 32 squared. Repeat those numbers. So minus 2 times 40 times 32. Oh, I'm going to run out of space. And how big is angle A?
$58 degrees.
Wonderful. All right, so try plugging that in your calculator. 40 squared plus 32 squared minus 2 times 40 times 32 times cosine of 58. Awesome. So what is side A?
Side A is 35.6.
Perfect. Meters for this one. Okay, any questions on using cosine law to find side lengths?
What were we rounding it to? Because I just did it to 36.
Oh, that's okay. This one didn't give us any specific instructions. Lauren, I'll make sure it's very clear on your evaluation what to round it to.
Okay, thank
So
you.
rounding to 36 is fine. 36 meters is fine. Okay, any questions? All right, now what we're gonna do is switch to solving for angles. So if you guys go back to this part of your lesson workbook, we're now focusing on this bottom formula. Okay, it looks a little bit weird, but again, it's just grab the numbers, plug them in, use your calculator, solving for an angle. So a squared minus b squared minus c squared over negative 2bc equals cosine A. So I'm just going to write that down. Actually, I put cosine A here on the left. I'm just going to flip it. So a squared minus b squared minus c squared over negative 2bc that equals cosine A. Guys, when you look at this formula, If you're solving for angle A, the only place you see side A is in this very first position, because angles and the corresponding side lengths have a relationship. Big angles have big sides across from them. Little angles have little sides across from them. So if you're looking or working with a triangle that's not labeled ABC, just follow this formula carefully. The angle that you're solving for, that will have the letter that has the same corresponding letter will be in this first starting spot. The other two don't matter. So if you were solving for angle X, side X would be here. And then if the other ones were Y and Z, you would just write them in the other two places of your formula. So the key is knowing that the angle you're solving for, you're going to start with the side across from it. Okay, this is the only common mistake I see with this formula is make sure that you focus on starting with the side across from the angle you're solving for. So if I'm solving for this angle, I'm going to start with this side length, 5.9. The order of the other two sides does not matter. So I don't even care if I started with 6.2 or 2.3. The other two don't actually matter. Just that first one matters. And then you repeat in the bottom, the second and the third numbers that you entered in the top. So I'm going to repeat 6.2 and 2.3. So if you have a fraction button, so if you have a calculator like mine, use the fraction button. It will make it easier to see what's going on in the top, what's going on the bottom. If you don't have that fraction button, you may have to simplify the top, simplify the bottom separately before you divide. So we're going to all play around with our calculators and figure out how to do this. I'm going to do it in 2 steps. So I'm going to simplify the top and then the bottom, and then I'll divide. But if you guys have that fraction button like I do, you can put it all in one step in using that fraction button. Please do this on your calculator so you know how to do this when you do some independent questions later on today. So grab your calculator, enter this in. I'm going to do it both ways for you guys so you can see, hopefully, the best way to use your calculator. So what I did here with my work is I simplified the top. I used my calculator to simplify the bottom. I'm going to do it actually all in one step here now, for those of you that have done that. How many of you guys are getting 0.31276, so on and so forth?
Yes.
Okay, so Sasha, anyone else?
Yeah.
Yeah, I'm getting
Okay,
it.
okay, wonderful, wonderful. Okay.
Yeah.
Good, good.
Yes.
Okay, you guys are making me very happy right now. Now, 0.312, that seems like a really small angle, right?
You gotta like reverse cosine it, right?
Very good. This equals the cosine of A, and I don't want cosine of A. So do cosine -1 of your answer. Cosine -1, and just use your answer button. So I'm going to just do that here, cosine -1 of my answer. 72?
Yep.
Wonderful. Nice job.
Yes.
Okay. Yay. Good job, guys. A equals 72 degrees. Questions on that one? Okay, let's try it again. Recently heard somebody say practice makes perfect, but that's not true. Perfect practice makes perfect. So we're going to do this together and we'll work out any errors. We are practicing this in the perfect way, confidently. Okay, cosine A, I'm just writing your formula here. I am again solving for side A, or sorry, angle A. So I'm using my angle formula. If I'm solving for angle A, what's the side I'm starting with?
Side A.
Good, so 36 meters, so 36 squared. The other two don't actually matter. I'll put them in the appropriate order based on the formula, but you guys could play around with it. It actually doesn't matter if I switch the 51 and the 46. Just the 36 has to be in that first spot. That's the one that matters. In the bottom, I repeat my second two numbers, so 51 and 46. And plug that in your calculator. However that works for you. So either with the fraction button or simplify the numerator and the denominator. So 51. Okay. I'm going to use my fraction button here. 36 squared, take away 51 squared, take away 46 squared. In the top, bottom is -2 times 51 times 46. Anyone get an answer there?
I got 0.7 and then the rest of the numbers.
Good. Okay. And you're like, Mrs. Reed said you'll never give me an angle less than 1. Okay, so how are we going to convert this into angle A instead of cosine of A?
You bring cosine to the other side and make it like the negative thing.
Yes. All right. So how big is angle A? Anyone else getting 43 degrees?
Yeah.
Okay, good. Any questions on solving for angles with cosine law?
Can you use this for sine law? Because this is so much easier.
You can't, Makai. If you have a loop of information, it has to be sine law. If you don't have that, then you need to use cosine law. We will learn tomorrow when we do our review. Once you've solved for a couple of missing pieces of information, then you do have options. Like for solving for angles, Makai, you've noticed you have to have all 3 side lengths, right? If you look at the first one, all 3 side lengths. If I look at the second one, all 3 side lengths. So if you had a loop of information and you use sine law to find the third side length, then you could switch to cosine law if you were looking for angles. But often your first step in solving a triangle, you don't have a choice. You have to use either sine law or cosine law. And then once you've done that, you could use the formula you like.
Okay, sounds good.
Yeah, unfortunately, that's the way it is. All right, we're just gonna do one last one. We're actually gonna be done the lesson before the break, so it's awesome. This is a word problem here, but often you guys can just easily figure out which formula you're using. I will always give you the diagram, so don't worry about that. This one says this is a boat trying to sail through a really narrow strait between that lighthouse and the rock. What's the width? What's he trying to get through here? How far is that? First of all, is it a right triangle?
No.
No, so this is not SOHCAHTOA. Do I have a loop of information?
No.
No, so it is not sine law. So I'm literally left with one option, cosine law. Am I solving for a side or am I solving for an angle?
Side.
Good. So I'm going to use my side formula. And if you guys want to just label what you're solving for A, that's fine. And then you don't have to rearrange anything in your formula. So I'm going to get rid of the X and I'll just make it A. And then it matches my formula here. And so if I'm solving for A, I'm calling this A, where's angle A?
At 26 degrees.
Very good. Good. So this is angle A down here. And B and C actually don't matter. All right, so A squared, don't know. I don't really mind if I call 4.2 or 5.3 B. I'm just going to plug them in. If you guys want to label it, you can. Minus 2 times 4.2 times 4.5 times cosine of 26. So plug that in your calculators. You guys should be experts at that now. 4.2 squared plus 4.5 squared minus 2 times 4.2 times 4.5 times cosine 26.
Yeah, 4 kilometers.
Okay, I'm not gonna round it quite yet, Lauren, because is that my final answer?
Nope, just kidding. You gotta like, don't you square root it maybe?
Yeah, perfect. Square root it. So 3.91, so on and so forth. That actually seems like a viable answer. So just double check, like, am I done? Because you might think, oh, actually, it looks like it's about 4 kilometers wide. But in cosine law, solving for sides, you do have to square root as your final step. So how wide is it really?
1.9 kilometers.
Good. What's it saying to 9 nearest 10th? Oh, I can't actually round to the nearest 10th because 0.97. So this rounds to 2 kilometers. So that's not a very wide straight there. Hopefully the wind doesn't blow him too far while he's trying to pass through because it's just under 2 kilometers. All right.